Hi, let's cover the Monty Hall problem from the game show Let's Make a Deal. In this game show, the contestant is presented with three doors. Behind one is a car, and behind the other two are goats. But we're going to leave those empty today because I don't have tiny goats for the demonstration. So the contestant picks one of the doors, and the host removes one of the two goat doors, which are the loser doors, and opens that up. So then you're left with two doors as a contestant. You can either keep the door that you selected, or you can switch to the other one. You would think your odds are 1 out of 3, regardless of what you do, so most contestants stay with what they've selected. But it doesn't work that way. It goes that there's a 1 in 3 chance of winning if you keep the door that you've selected, which makes sense to your hardwired brain, but if you automatically switch when given the option, you will win 2 out of 3 times. Now, most people don't particularly understand that because your brain's telling you that's not correct. It doesn't matter which one you pick or switch to, it's going to be 1 out of 3. But it is 2 out of 3 if you switch. So, we're going to show you as you're the host, and the car is always going to be under the orange cup in this case. So we'll go through the first permutation and we will keep it where the contestant stays, and we'll go through all the different options. So the contestant picks cup 1. I, as the host, know this is the only other empty one, so I remove it, but you stay with this one. It has a goat. You're a loser. You pick 2. I have to, as the host, remove this one. You still stay with what you have. That is also a loser. You pick 3. The host can remove either of these 2 because they're empty, but if you're going to stick with it, it doesn't particularly matter. You're going to get the car. Congratulations. So in this scenario, we have loser, loser, winner. Now, let's do the same situation with the doors, but with a mandatory switch. So you pick 1. Now, as the host, I have to remove 2. You'll switch to the other option. That's 3. That's the car. That's a winner. You select 2. As the host, I have to remove 1. You switch. That's the car. That's the winner. Now, if you pick 3, the host can remove either of these. You switch. It's still going to be a goat. So then you have win, win, loss if you do an automatic switch. Now, this is only because there is additional information that the host knows where one of the other loser or goat doors is and removes it for you. So in every scenario, if you stay, you'll have a 1 out of 3 chance because you have to pick the car right off the bat. In the other scenario, you can pick either of the goats and do an automatic switch and you will win. The only time with the automatic switch you will lose is if you pick the car right off the bat. But since there's a 2 out of 3 chance of picking one of the goats right off the bat, that is your % chance of winning. So you can double it by switching. So maybe that explained it, maybe it didn't for you. So we're going to move the car into the middle. We're going to run through the same permutations. So this one was staying. You pick 1, I have to remove 3. You stick with 1, you lose. You pick 2, I can remove either one. You still stick with what you have, so it doesn't matter what I remove. And in this case, you'll win. You pick 3, I have to remove 1. You still stick with 3, you're going to lose. So in this case, with staying, it's loss, win, loss, 1 out of 3. With the automatic switching, you pick 1, I have to remove 3. You switch, you get the car. You pick 2, I'll remove one of these, and you're going to switch to the other, and that's going to be a goat no matter which one it was, because you picked the car first. You pick this one, I have to remove this one, you're automatically switching, you get the car. So it's win, loss, win, 2 out of 3 chance. So we can keep going here. It's not going to change anything, but doing the staying parameter, you pick 1, I'll remove one of these, you're still going to stick with what you have, and that's the car, that's a win. You pick this one, I have to remove this one, you're going to stay, you're going to get the goat and lose. You pick this one, I have to remove this one, but you're going to get the goat anyway, because you have a 1 out of 3 chance. So we have win, loss, loss while staying. So let's do the switching parameter. You pick this one. As the host, I'll remove one of these 2. It doesn't matter which one. You're going to switch. It's going to be a goat. That's unfortunate. You pick 2, I have to remove this one, you switch, you get the car. You pick 3, I have to remove 2, you switch, you get the car. So once again, when you do an automatic switch, it's loss, win, win. 2 out of 3 chance. It is very important that the host knows where the empty or goat door is and is forced to remove it after your selection. That's the key information that changes the odds. But most people, including myself when I first saw it, said no, my brain did not compute that that was possible. So hopefully that, without the mathematical equations, just the display, showed you how the Monty Hall problem is real, that switching is always your best bet. Thanks.